Hello, everybody, and welcome to this very special webinar, ChatGPT and Beyond, the new data center approach. I feel like I need to do a disclaimer. No, this webinar was not written in ChatGPT. I don't know why everyone keeps asking me that. This is a completely natural conversation. I am not reading what a machine is telling me to write. Or am I? I'm not. I promise I'm not. Thank you for joining us, everybody. And by the way, Dean and Kostya and myself, we love an interactive audience. So please ask us questions. Connect with us in the meantime. We're going to be keeping an eye on the chat window here. It's public, so just don't be shy. This is a chance for you to ask some really important questions about something that I'm sure everyone, even in the mainstream media, my goodness, is seeing in the news. Let's start this conversation. I want to kind of set the lay of the land, and then we're just going to jump right in. So we wake up, literally we wake up, we put on these little watches, we interact with our little devices, and from the start, we are generating data. From the second that we open up our eyes, sometimes when we're sleeping and wearing these devices, we generate data. And we interact with the world around us because it is a connected world. However, every single click has an impact. And according to the International Energy Agency, the IEA, data centers consume about 3% of global power, and about 1% of global emissions come from data centers. Now, that number fluctuates, and it's only going to continue to grow. The goal becomes a broader focus on the future of energy and creating sustainable data center solutions to work with one of the most important aspects of our lives, data. And that's not going anywhere. This is a very special webinar. We're going to be talking about this, and I'm really happy to be joined by Kostya and Dean. I'll introduce them in just a second. Really, for the first time, you're going to hear about a platform that sustainably trains data with deep intelligence into the overall carbon footprint. And you're also going to learn about a low-cost, low-carbon architecture, this bare metal solution that is going to impact everybody. Here's the bottom line for what we're talking about. If all of you want to know where this is going next, this is it. This is the conversation. Machine learning, AI, data management, and working with sustainable solutions. So I'm really, really proud and happy to announce two amazing people here. Dean Nelson, CEO of Cato Digital, founder and chairperson of iMasons. Hi, Dean. It's great to have you here.
Great to be here, Bill.
Thanks, Dean. And we have Kostya, Constantine Goltsev, who is the advisor, and you're going to hear me call him Kostya, advisor and board member here at Neu.ro. Kostya, it's really great to have you here as well. Awesome. And I am Bill Kleyman, also investor and board member at Neu.ro. And I may or may not have something to do with Infrastructure Nations. I'm just kidding. I'm very much a part of the organization and very proud to be a part of that group as well. All right. Listen, I don't have an agenda slide. I don't have like a table of contents. We're literally just going to jump right into one of the first things that we're going to do. I didn't want to save this for the end of the webinar. Okay. An announcement, right? Neu.ro is partnering with Cato Digital, and we're going to be increasing the performance of machine learning and generative AI while reducing carbon emissions through Cato's groundbreaking low-cost, low-carbon bare metal solution. This is a brand new announcement. So if you're hearing this, you're going to be seeing more press releases, more published articles. It's a very special announcement because for the first time, listen, and you're going to see this later on in the webinar, people train data, people train models, but this is the first time we're actually having a very concentrated focus on you can train your models, but we're also going to tell you what the carbon footprint is and how you can effectively reduce that. And I'm so excited to be doing that with Dean Nelson and certainly Cato Digital. Now, let's just jump right into the rest of this chat. When we take a look at information and what's been happening with data sort of in general, we have to know that, my gosh, the past, let's say, not even decade, the past like 5 years have been a masterclass in our connected world. And this is where I want to start the conversation. What is the current state of data? And I'll let Kostya and Dean's gears start churning here a little bit. And how can we really grasp the amount of information that we're working with? Now, before I go on, this whole thing with ChatGPT, this whole conversation with generative AI, these long language models, these trained models that we're creating out there, it's really different. Please understand, these aren't your traditional chatbots. These are truly immersive contextual engines that can converse with you. And so we come to this statement. All right, everybody get off your Amazon shopping list. Come on, read this one slide with me, and then you can go back Googling stuff. I'm just kidding. Hopefully you're paying attention. AI is a powerful technology and a force for good. Now, everybody on this webinar, we believe that. But it's important to be conscious of its growing environmental impact, and not just that, also the ethics behind AI. This isn't this kind of curve. This is not. This statement is a rise, a meteoric rise in concepts that please everybody on this call understand. We'll talk about how fast ChatGPT got into this world, but oh my goodness, let's talk about the state of data. Let me start with you, Dean. What do you think? What are you seeing out there? And certainly in the sense of like how much energy this data is consuming. Where are we right now in the space?
I think it was in 2020, they were making predictions about the data generated per year.
That's right.
And so the expectation is that we were going to get to 175 zettabytes of data generated by 2025. And so if you think about the zettabyte, right, that prediction didn't have anything in mind with ChatGPT or any type of this modeling type explosive growth. So based on the numbers that they've gone through, that number is now going to be towards 250 zettabytes in the same time frame. And we believe it's going to be even higher. So the amount of data consumed is directly proportional to the amount of compute that's actually done, to the amount of storage that has to be there, to the amount of energy consumed in data centers to actually process that information. So when we think about your numbers at the beginning, today we have 7 million data center locations. They have 105 gigawatts of capacity. They consume 594 terawatt hours of energy every year. This is digital infrastructure holistically. That represents 2.4% of the global energy draw.
Mm-hmm.
Okay, so for everything we're doing, including this webinar, that goes over a network, into a data center, onto a server, right, in a storage component, and does work. So that growth over the last 20 years has been, steady when it comes down to the amount of data, but it is now compounding because of things like ChatGPT. And so we've done a whole bunch of stuff in the data center sector of the industry to optimize. And I think that there's a lot of low-hanging fruit that's been picked, because if we hadn't have done that, we would have been in double digits for consumption already. But now when you look at the demand coming back in, because today we still have 2 billion people that are not on the internet. Okay. But we also are going to 135 billion things by 2030. Those things will have 1 trillion sensors behind them. All of that is going to be driving the data consumption. But now you've got a model like ChatGPT or any of these other GPT-like services that are being done, such as on Neu.ro. That's going to now grow that data even more. So we said this before, Bill, it's a data tsunami. And that's not an exaggeration. It is a massive wave of data. So the amount of data generated, I think over the next 5 years, this isn't certified by other people. I believe we're going to generate more data in a year by that period than we have in the history of mankind. Think about that concept. That amount of data is going to become its consumption. So from a GPT standpoint, everybody is going back and running these models to do what? Give insights to people and machines. The machines are going to be 135 billion with their sensors behind them, with the 8 billion people. So hence you can see why this data that's being generated is going to drive so much consumption. It's going to now go back to the how do we sustainably grow digital infrastructure to meet that demand?
Everything that Dean is saying, Kostya, I'm going to bring you in here for a second, is so spot on. And sometimes we have these blinders on that we forget just how big and connected our world is. For a second, there's a Deloitte research that just came out recently that said the average U.S. household has 22 connected devices. Now, timeout, right? We've got all these smart, wonderful people on the call that are digital technologists. Take a look around you. I mean, I bet you by the time you're done counting, you have more than 22 IP addresses or devices in your own house. By the way, total side note, I love this conversation that's going on in the chat window. Hi, everybody. Hi, Greg, Peter, Will, and Simon from all over the world. I love this webinar. And by the way, keep the chats going. If you have a question or a comment, we will stop this webinar. We will ask your question, especially if it's good. All right, Kostya, we're on the first question here. You are a person that swims in data. You literally help train how to data to swim. How are you seeing this change? What are you seeing emerge? And most of all, what is the state of data today?
Yeah, I mean, it's gigantic. So part of the reason is that these new foundational language models that are come out, they're called large language models, and they're called large for a reason. And they're just of titanic proportions. So something like ChatGPT might have 500 million to 1 trillion parameters. And these are these little knobs and dials you actually have to turn each time you train the model or do the inference. So typically, even deployment of such a model would require a rack of a server rack with 8 cards working at the same time, each sipping 300 watts to just respond to your ChatGPT query once, right? But when you train the models, it just becomes ridiculous because, for instance, ChatGPT purportedly was trained on 25,000 GPUs over the span of 6 months in Microsoft, which gave the compute to OpenAI. And now each of these GPUs draws around 300 watts of power. So that's 7.5 megawatts per hour that this puppy is sipping. And you multiply it by 180 days, and you add the server load that's probably going to double everything. You're probably looking at 2.5 to 3 gigawatts of power that took to train that one GPT model. And this is first of many being replicated in the industry, dozens and dozens and dozens and dozens. And there's a good reason for this. Mathematically, there is something in the core of these models of the success called a transformer. Nobody found a way, and not likely that a way to compute it non-quadratically. And quadratic in computer science means that it's voracious for bandwidth, for computation, and just the number of operations required. So these, based on the business success of ChatGPT already, there's doom prophecies of disruption where it's going to take everybody's job in the next 2 years, and likely it will take some, right? Driven by that business frenzy, investment is going to happen, and there's going to be more and more and more compute, data and power and infrastructure thrown into this. So this is totally going on exponential takeoff.
Wow. I'm sitting here listening to this. Upwards of 7 megawatts per hour to train, Quista? That's...
Yeah, to train large foundational model on industrial scale. So this is a small town or larger.
Wow. Okay. Well, folks, I'm in surprise here because some of these numbers, Quista's like, don't worry, Bill, I'll prepare them and you'll hear them on the webinar. So some of these numbers I'm hearing for the first time. And everybody listening, I mean, this is real. This is not just sitting somewhere. This is going to be in your warehouse, in your data centers, in your facilities, and we need to understand this. So let's kind of continue this conversation, right? So, Quista, you mentioned data modeling, right? And it's changed. Oh my goodness, has it changed over the past few years? And I'm really curious to kind of learn a little bit more about how far we've come. Now, you mentioned large language models and sort of the future of AI, and you're throwing out some really good numbers here. And for everybody in the call, I think this is important. For some folks, AI and large language models are foreign, right? This is maybe newer to you. So let's visualize this a little bit. If we take a look at large models in the future of AI, holy cow, and Dean, you're going to see this as well. Quista, I want to bring you up to talk about this a little bit. You've seen this transformation from the early days of ChatGPT 1, right, to ChatGPT 4 today. Help me understand this a little bit. How has the future of AI been impacted today? And what are we going to be expecting in the future, especially now that we're seeing these kinds of metrics?
So again, it boils down to the latest research, and researchers were stunned themselves how effective GPT-3 level models were at conversing, producing coherent speech, and even some would argue understanding speech and having all these emergent capabilities. And it all happened because of very interesting mathematical fact that people have discovered.
I think we lost Quista for a second.
Yeah. Let me.
Yep, we did. All right. Well, he's going to tell us about that mathematical discovery. I'm sure everyone's on the edge of their seats here.
Yeah. So the mathematical discovery was that large models work much better than smaller models, and that was uncanny, because it turns out that if you take absolutely huge model and give it less data than the smaller model, it will actually perform better, much better. So people start going for larger models, and that trend continues. It has to do with something with multidimensional space. If you imagine, three-dimensional space, there are only so many ways from A to B that are short, right? Like there are one or two on a sphere. But if you take multi-dimensional space, you can kind of in hyperspace, there's so many ways shortcut through many dimensions.
That's really fascinating to think about how much we've evolved. And Dean, I'll ask you this really quickly. You know, you started. I mean, you literally helped build the data centers at Uber, and you've seen how these disruptive new technologies have impacted our industry firsthand. What do you think about this?
I honestly think about any tool that comes out. You can use it one of two ways. One is a tool for good, and one is a weapon. And so, and there's another dimension of this that is really important too, which is there's going to be some kind of counterbalance to it. This growth of data is huge. The consumption of compute is huge, but it's going to come down to the economic impact. So when I think about the way that the ChatGPT is generating value, right, how people are leveraging that, it is going to be countered by the amount of cost is associated with doing the work, right? And so I think that's going to temper some of these things, because no matter what, you put a bunch of things out there, people start using it, and if you're not generating the revenue from it, it's going to hold things back. Now, if you think about progress we're making from a ChatGPT type function, any of these models, what are they doing? So when I'm using this to go calculate what the sustainability impact is on X, Y, and Z, or think about cancer research, and I'm running a whole bunch of models to understand more things, the output is incredibly valuable. There is some thing that comes out of that, so hence for good. But then you've got the other side of it is that I got to balance out that I can't go out of business when I'm running these things. So no matter what, these new tools are coming out, and how we use them, they're still going to be tempered by how much they cost.
Yes.
The data generated directly to the actual power consumed, to the data centers that are running them. I mean, it's that entire stack will be testing this itself. But I think the key point in this is ChatGPT and all of these type of AI and ML models are here to stay. And they are bigger and more impactful than anything we had thought about before. Think back 20 years ago. You talk about computers that are going to do the work for you. It literally is doing the work for you. ChatGPT, write me a press release for Neu.ro and Cato. It knows a ton of stuff about us. And if you think about that, you can tune different things within that, but my God, 80 to 90% of that is accurate. So that suddenly makes everybody's productivity go up, but at the cost of power consumption, right? And then that's where we double click back into the sustainability aspects.
Dean, it's as if you know what the next slide is. Because what you just said something really important. And by the way, I love this chat that's going on. Don't stop, people. Keep posting comments and questions in there. Dean, Costa, and the rest of the team are looking at this. And Greg, you said something really, really important. Recently, I've been thinking a lot about how we need to do a better job as an industry sharing the positive impacts and positive offsets of digitization in the world, generative AI, and ensuing power consumption is going to escalate this need. Absolutely, Greg, and we certainly agreed with that. And keep that thought in the back of your head, right? AI and ChatGPTs are certainly opportunities. They're business opportunities that we are still only scratching the surface of and trying to understand. Questa made some really brilliant points there. Behind every ChatGPT session is a server that costs $120,000 to $150,000, and it costs between $16 to $20 an hour to run. These are not inexpensive machines. And we'll talk about that true cost of it, right? And what is the ultimate cost of what we're seeing out there? When we take a look at ChatGPT, and Questa, I'll bring you in here in just a second. AI bot ChatGPT reached an estimated 100 million active monthly users, faster than any other application in history.
Insane.
In history. I mean, look at this chart. Please look at it. 5 days. 5 days to 100 million users. Good Lord. And this is the wild part of this, is that this does ultimately come at a real cost. There's a saying out there, and Costa, I'm going to pass this off to you in a second. A single Google search can power a 100-watt light bulb for 11 seconds. These aren't Google searches anymore. They're not. Costa, what's the cost of this?
You can only guess at estimation, but it's over 100 times more, literally. than a Google search, over 100 times more. I mean, with some optimizations that OpenAI and Microsoft are doing, it might be sliced by a factor of 5, but it's still going to be 20 to 50 times more than an average Google search. And then the problem is, the more sophisticated the request is, the more power it will draw. So think about, initially, these are just regular users who did this transformation, but when all the enterprise goes that way, right, it's just going to explode because they're going to produce very sophisticated queries. So the power is going to be, prodigious.
And it's wild. Dean, you had your finger on the pulse of the power sector for a very long time. This has to be alarming to some extent, right? You've seen traditional compute and now this. What do you think the true cost behind this is going to be?
10 years ago, everybody was predicting we're going to have liquid cooling and the amount of compute is going to go through the roof and those types of things. And if you look at what caused that, we still have had a predictable growth when it comes down to the power consumed within data centers, because in the end, it costs somebody money. And I keep bringing this point back. So that is a balancing act, right? It is an equalizer inside of it. So the data centers and the actual partners in the data centers, plus the customers in the data centers, are still trying to figure out what is the cost per unit, right? That's going to be directly proportional, again, to the watts consumed per unit. The unit of measure is the thing here. What's changed is that unit of consumption has gone up exponentially, just like Constantine was talking about. The ability to go back and run something as simple as a ChatGPT-like, right, request or query is going to drive consumption up. So when I think about the past, when we look at that growth of power and data, and then we start looking at the hockey stick that you were talking about, Bill, as that starts going back up, there's going to be an equalizer inside of it. But no matter what, this is all driven by user demand.
Yeah.
Period.
Yeah, clearly.
This is not just, so do you remember Noel
Yes.
Walsh on one of our things when we came out in Infrastructure Masons with our sustainability vision? This is that every click improves the future. Every click improves the future is a loaded sentence. That means that, it enables economic growth. It enables people to have opportunities and jobs, etc. But it also means that we're going to do it sustainably in the infrastructure. I remember in my interview with her, she said, during the pandemic, here's another forcing function. When they had to meet teams, all the gaming, everything else, they rolled out 100 megawatts of new capacity in 2 months. It just blows my mind to be able to have that much capacity turned up that fast. Now that's because of a catastrophic thing across the world, but a forcing function that forced everybody online. I'm going to work from home. Cool. Now here's another catalyst. When you think about it, the GPT-like services or just anything ML and AI, now we see it being adopted. OpenAI's rollout and things with Microsoft suddenly showed the ability to say, I can do some productive things with this. With one request, how many billions of different things within that training model actually are being leveraged? So the consumption will go back up. But no matter what, that balancing factor, another call out. Remember what Christian was saying, Christian Bellotti over at Microsoft? He said that we are the most innovative when we're under constraint. So that constraint is going to be forced by what does it cost for us to do that? That's going to go back to the businesses saying, how are people leveraging this service itself? But make no mistake, these companies are not dumb. Google, Microsoft, Amazon, Meta, Apple, all of them are figuring out ways in which we're going to leverage this platform, these platforms themselves, this capability, to enhance their business opportunity, the relation to a person's opportunities themselves. That all is going to go back to, I'm going to go have an engine that's extremely efficient, that's extremely effective, that is going to make money. So this tension between the consumption and the actual money made will be the forcing factor that says we have to be efficient. I believe we have to take one step further in that, is say, now we have to make sure everything we build is sustainable, no matter what. Every click improves the future is about making sure you're going from the concrete up to the platform to the consumption for people. You must have a systems view, holistic view into that one, or else we're not going to make any difference in the infrastructure that's built. Because remember the 7 million data centers with 100 gigawatts capacity? You're talking about hundreds of times multipliers of consumption driven by demand from users. That's going to continue to grow up. We must, and I can't emphasize this more, make sure that every building, every deployment of compute and storage inside of it, all the networking is as sustainable as possible. Must be.
Again, Dean, you bring up such an important point. In sort of like the next part of the conversation that I wanna talk about here, as far as understanding the cost and impact of this. I threw up a poll, guys and girls, everybody on the call. Go into the poll and see the question over there. I'm really curious. So far, we've got about. Oh, there we go. Everyone's answering. I'm curious to see who here has used ChatGPT. Look at this. I mean, this is totally indicative of why there's 100 million freaking users in the first 5 days of this. Almost everyone's responded. Thank you so much. 88% of you are coming back and saying, yeah, we've tried it. You know, it's really funny. I was talking to Dean about this the other day. You can Google yourself. You ever tried ChatGPTing yourself? It'll write you a narrative about you and who you are. And it was kind of like, whoa.
It's scary.
It is a little scary. I'm like, all right, cool. I guess you know a little bit about me. By the way, again, love these questions that are coming in. Ken, Logan, Vova, these global international questions. I'll be reading these out here in just a second. And by the way, if you have more, we will have a little bit of time at the end to cover these. Okay, these next couple of slides are going to be really important because, again, I don't just want to talk about the technology. Everyone on this call is going to experience ChatGPT in one way or another. We need to talk about the base, the impacts, what everyone on this call in the digital infrastructure space understands. So Dean said something really profound and very, very important. When we start to take a look at legacy data modeling and focusing on the results, we realize that for the longest time, even through today, like Neu.ro is truly an exception, and working with Cato makes it even more so of an exception, actually. We'll talk about it in a second. We used to focus on the results time and time again. Large language models, large data training models, results. We didn't care what the footprint was, the carbon footprint specifically. And that's really scary because it's changing with smarter deep learning models, these larger, much larger large language models like Kostya was talking about a little bit earlier. But here's like the really profound statement, right? With more AI and deep learning data, all this data that we're creating is going to impact sustainability. In fact, data that we create is going to impact sustainability more than anything out there. This includes the underlying infrastructure that's being tasked for supporting it. And so the conversation becomes the cost of improvement is becoming unsustainable. That's real. Please, I'm not just like, hey, Bill Kleyman, lots of coffee. This is kind of serious. And this is amplified not in a twice-fold manifold or 3 times where, let's say, Google became really better. Like this is upwards of 100 times more intensive GPU, CPU, resource intensive than those pretty little blue links that you and I and all of us are so familiar with. Kostya, I'm going to bring you in here for just a second. The cost to train a data model. I would say like a couple months ago in January, last year, no one knew what ChatGPT was. No one really tried it. And they maybe like heard about it or something. Mm-hmm. And in the span of a week, we went from nothing to everything. And it's just becoming much more unsustainable. Right now, we're in this little gray area where we can keep up. Where we can kind of keep up and try and figure out, but eventually we're going to be out of that gray area and we're going to be in trouble. Kostya, I'm going to bring you in here for just a second. A 571% increase in the cost to train a model. Talk to me about this. How is this changing, and what do organizations need to think about when they're looking at data training and data modeling?
Yeah, so this is an artifact of that math fact, as I said, right, that we really need large models that perform better, and that wasn't expected. And then larger models are going to perform even better. So the next step that everybody took was, let's make it huge and huger and huger and huger. And that capability, people would chase that capability and make things larger. So the exponential, the order of magnitude jumps are likely to become a norm.
Absolutely. And can you remind everybody, do you remember when ChatGPT 3 versus ChatGPT 4 came out?
Oh, literally, I think ChatGPT 3 came out in its form that was interested to everybody. I think literally October. So we are seeing change on the span of months. This is a truly kind of acceleration type of event that looks like an explosion.
Again, if you want to know where the puck is going and where we're going, your infrastructure, your facilities are going to be a part of this. If you want to be a part of this next iteration of data usage and smart and AI and generative AI, you're going to start to have customers come to you and say, "Hey, how do I train these models, or do I just need to go to the cloud? What are my options here?" Dean, I'm really curious to get your perspective here as well. The cost to train a model and how that's all changed. You've seen so much of the world from a traditional compute perspective, and now you're looking into this new lens. What does this mean to everybody?
Yeah, and I'm going to be the balancing voice
Please.
in this, because what I want to make sure is we're not causing a panic of people to say, oh, we should not be using this
Good
capability.
point.
We should absolutely be using this capability. Now, the forcing function I was talking about before. If you look at this is like when everybody goes out and says, oh, I want to use this capability, I want to do these things. You're not looking at the cost or the implications of using it. It's like driving a whole bunch of miles with a combustion engine. You're emitting more CO2, right? And in the end of it, you're going to go, wait a second, that's costing me money. I gotta be careful on how I do that. That's the balance. So when you think about these large models that Constantine was talking about, it reminds me of Uber when we were doing the autonomous vehicles. So on my team, we had all the data centers and also the hubs. The data hubs are the places where the cars would come in. Okay, so they're out there modeling the streets, doing mapping. They're doing a whole bunch of things when it comes down to modeling or training the inference, understanding what it is they're seeing, what they're going to avoid. That's a person, that's a sign, that's a something in the road. Those models that were done when they first did it was kind of like ChatGPT 4. If you think about that, they said bigger the model, bigger, right? More data, better, better, better. But they realized they didn't need to run it that way. And I want to get Constantine's view on this as well. They went back and said, you know what? I'm loading the entire model in here, but I only really need to see a snippet. Okay, that's for a very specific type use case. But that snippet itself was like 1/100th of the amount of data that had to be looked at, the compute itself. So my point of this is that you've got very large companies behind these things when it comes down to what models are running, what consumers are going to be leveraging when it comes down to the GPT-like capabilities. They're going to figure out ways to optimize. And the optimization is going to go back and say, I'm going to be efficient when it comes down to what I put in, what I run to get the result I want. I think we're learning in all of this. The difference is that all of a sudden this demand that's coming in is forcing these kind of numbers. People want to be able to see this thing quickly. So when I have 100 billion parameters, I'm going to go back and get a more accurate thing. But I think Constantine said that, or it was you, Bill, that we actually would have less things, but running on a bigger scale to get a better result. My point is that tuning is going to continue to happen. This is a capability that's going to move people forward.
Mm-hmm.
But at what cost? Both from the dollars to the consumption, to the actual power, to the sustainability from a carbon standpoint, will be balanced out over time. But make no mistake, again, the amount of consumption in digital infrastructure is ticking up because of things like this. How fast is up to all of us.
Yes, I mean, it feels like we're staring into a crystal ball, and the crystal ball is saying, "Listen, I know we're forecasting the future, but this is going to happen. How do we prep for this?"
It's inevitable. Yes.
And so, okay, so Costa, let me bring you in. Actually, Dean brought up a really interesting little side question here. And by the way, I agree with you. Tuning is going to be a big part of it. Costa, is this how you get a handle of it, right? Ultimately understanding that these technologies are going to be a part of our future. There's no if, it's a when. And is tuning and more intelligent control of both the platform as well as the underlying physical infrastructure a means and a method to do more with less effectively. Right, Dean?
Yep.
Costa, what do you think? I think.
Yeah, I think exactly quite right. I think it's going to balance, and the training is still going to happen on these huge machine farms that are, pushing the edge of foundational models, but then fine-tuning is going to be leaps and bounds more efficient. So it's going to be a happy balance between, innovators and users. But then, there's also going to be a lot of innovators, because one's consideration in these large language models is that they also raise questions that are not typically associated with regular data. For example, they're controlled by prompts, and they're controlled by very thorny issues with data sets, whereas these data sets also have opinions, political kind of views, and also these models do learn the data. So a lot of large organizations wouldn't want to share, their mother load of data with Microsoft or Google or whoever. They would need, maybe because of regulation, to keep it all in house. So they'll have to innovate, and and there's going to be the whole gamut of this usage, but not going to go down. It's going
Looks like we may have lost Kostya. By the way, we're spread all over the world, so sometimes the internet isn't always great wherever we are. There we go. Well, Kostya will be right back. Is he on here with us, or did you just leave for a second? Looks like he left for a second.
He stepped away.
He'll come right.
His computer has stepped him away.
He'll come right back. All right. There's still continues to be a whole lot of really wonderful questions coming in. I love this chat. All of you are amazing people. My gosh, on a Wednesday morning, no less, we have very verbose individuals. I'll take it. Thank you. There's been a couple of questions, Dean, that I think I want to stay on here for just a second. My gosh, there's one question here. What is an electronic equivalent that can help AI navigate power usage in unexpected ways, from Ken? And I think that's fascinating. One of the things that, and Dean, I know you've got a great answer for this one. So one of the things that Neu.ro does is we are a MLOps platform, right? We are the underlying architecture where we can take all of this data and do a machine learning neural network architecture that will train data models based off of all the information we collect to generate any kind of output that you want, right? Much different than linear traditional AI that might see a pattern, give you an output. This is so much more contextual. Now, to the question, well, cool, Bill, that's great. How do you, ultimately control power usage? Within Neu.ro, we were the first ones to actually ever do this. It's called an energy scheduler, and we can look at the underlying physical infrastructure and see when are you training data? Why are you training your data at this time? What is the cost of power at this time, for example? And so we can actually intelligently change the training schedule. Still the same result, but on the dashboard, you will see your dramatic reduction in carbon footprint, because all of a sudden, oh my gosh, you have direct visibility into the carbon footprint of your data that's being trained for generative AI, your generative pre-trained transformative models, ChatGPT, that's the acronym if you didn't know, and all of that. So we're going from that earlier slide, if I'm not mistaken, where we talk about how we're training all of this data, but at what cost and what visibility? Well, now we're understanding that cost and we're having that visibility. So that's how we're trying to do this different. We know that we're going to be getting more data, but we need to change the paradigm of how that's being trained and give you the power. We'll give you the complete control over how you actually change the scheduling and all of it to reduce carbon footprint. But you still need the underlying infrastructure. Dean?
Okay, so I'm going to tie this into a couple pieces. So if you think about what Cato and Neu.ro are doing, Neu.ro is giving you insights, not only the capability to run the models, but the insights into what it means to run the models. Now, that's really important, because what we measure, we can actually change. So when you see it, you can do something about it. Now you'd say, wait a second. Oh, so if I run this at a different time, it'll cost me less. It'll use less power. There's a whole bunch of factors for it. But the reason that you have that in front of you is to now make those decisions. Now, those decisions can be automatic as well, that the machine will start to tune itself. to make sure that it's using the least amount of resources to get the same result,
Mm-hmm.
as Bill was saying. But the other side is, remember, 2.4% of the energy draw today, with impacts of things like GPT, we're suddenly going to have that go up, which means that we must have the infrastructure that's deployed as sustainable as possible. Because we should not be limiting the consumption of new technology that's going to advance humanity, because we don't want to be penny wise and pound foolish in this. We have to go back and say, look, you're going to run these things. You're going to be driven by economics. We, as the underlying infrastructure for the Internet of Everything, and I'm talking about all the different companies that build the foundation that enable models like this to run, have to build it sustainably. So now when we go back and look at what we're doing together with Neu.ro and with Cato, Neu.ro is giving you insights, letting you be able to run all these models, right? The advanced technology from a software and platforms perspective to be able to do what you want to do. Now we have to do that cost effectively and sustainably. So what Cato is doing is building low-cost, carbon-free compute. That is our vision. So to get to carbon-free, that means that the embodied carbon and the energy consumed and the carbon associated with it have to be as low as possible. When you build new equipment, no matter what, you're building a new embodied carbon footprint. What did it take to get that server to where it can be plugged in a data center and used to run something like this? That's the carbon history. Then you look at the building itself that it's operating in. It had to be built. There's a carbon debt, right, that's actually built for the building. So those two components are the embodied carbon. Then you look at the power consumed to actually deliver the result like this. That is source energy. Where is that coming from? Is it renewable? Is it clean? Is it dirty? So when you now add all those back up, this is what Neu.ro is looking at. What's the carbon impact? So then let's go back and change the numbers. If we can now bring in things that are going to be avoiding the carbon at the beginning, this is the core of what Cato is doing. We're using second life equipment. So think about it. Equipment that's been used in hyperscalers and all that for a period of time. They've retired it. They have offset the footprint of that stuff, the embodied carbon history. When we receive it, it is zero embodied carbon. We're starting at a lower point. Then you put it into data centers, and our software is leveraging only the wasted capacity in data centers. Of that 105 gigawatts, there's 37 gigawatts of power capacity that's never used. Okay? So there are 43 million servers being retired in the next 5 years. 43 million. Instead of them going to parting out, or right, from a recycling standpoint, we take the ones that actually still have life and we move them back into the system. So we avoid that entire embodied carbon aspect at the beginning. Then we put it into data centers, and those data centers via software allows us to be able to use the things we could never use before. Then you have clean energy in that data center. So this is how we're getting the underlying infrastructure to be low carbon and eventually zero carbon. So now we can enable models to run where we don't have a sustainability trade-off. That is the core of what we're doing at Cato. And the reason we're doing that is to make sure that we, as we grow from 2.4% of energy draw up, we do it sustainably. The only way to do that is avoid the use of resources that are going to have more carbon impact. That is a huge component of what we have to do. So I believe in circular in a big way. We're doubling down on that. Then you say capabilities like Neu.ro give you the visibility and the capability to go back and run the things that will advance your business, advance your life, advance humanity. That's the balance we need to achieve.
That's extraordinary, Dean, and thank you so much for sharing that. I think that's really important, right? We're literally talking about a means to create a, oh my God, it's like circular economy, generative AI. That just sounds awesome. And I think that's really, really special. By the way, thank you for all of these wonderful questions coming in. We're going to start to wrap up here and see if we can get into some of these questions that that everyone's asking. So thank you so much for all of this wonderful conversation here. I'm just trying to catch up. Okay. At this point, we're gonna shift a little bit. We'll talk a little bit more about Neu.ro and specifically what Cato is doing from an organizational perspective, and then we'll open up the floor for questions. So when when I left Switch in January, I was like, oh, I'm going to take some time off. I'm going to relax a little bit. That didn't happen because Neu.ro came to me and they explained what they were doing. And people ask me often, Bill, where are we going next? What are we doing next? Well, part of the reason I didn't take any time off was because I saw where we were going next. And this is it. Generative AI, ChatGPT, large language training models, data training in general, and how way more traditional customers that never would have even spoken those acronyms are going to be asking and talking about those acronyms specifically. So at Neu.ro, I joined a team that is delivering state-of-the-art AI systems, a complete machine learning ops stack that's built with best-in-breed tools, literally as easy as you can possibly make it. The story of the organization is absolutely wonderful as well. A Ukrainian company that has been brought here to the United States, right? So that's really, really exciting. We have a well-made, well-thought-out product that we're building here in the U.S. With a complete ML pipeline support, white glove support, obviously. And like I talked about earlier, this industry-unique energy scheduler to optimize trading schedules and lower data carbon impacts. There's a couple of questions out there how we can do this, and that's a part of the method. Plus our ability to directly deploy on top of low carbon, low cost, and ultimately low cost, zero carbon. Holy cow. Can you imagine that for just a second? Zero carbon generative AI architecture. That is the coolest thing ever. That's part of what we're trying to accomplish here. Kostya, let me pass it to you here just a little bit more. Before I do, I think that's an important one. Kostya, sit tight. And a part of what we're trying to do here, as far as reducing the carbon footprint, is we have to be a part of something big, a part of something special. Dean, what am I looking at?
Just very quickly, Bill and I were involved in the formation of the iMasons Climate Accord. And that basically is a consortium of companies that are going after the reduction of carbon emissions to get to carbon neutrality as the first step towards net zero. Now, what does that mean? That means these companies are coming together to drive digital infrastructure's carbon footprint down. We have over 200 companies within this, including AWS, Google, Meta, Microsoft, Cisco, Schneider Electric, Digital Realty, 75 co-location companies. It's massive. So that allows us to be able to now zero in on what can we do together, like what we've been talking about. How can we drive down the actual emissions from digital infrastructure? So when we grow sustainably. And just to get an idea, this group of companies represents $6 trillion of market cap. There is massive buying power behind this. So by doing this, that means we're putting our money to where our RFPs are. And the RFPs are going to drive sustainable buying. The sustainable buying is going to drive sustainable building. The sustainable building is going to deliver the capability for everybody to consume infrastructure such as GPT-like services sustainably.
Awesome. Thank you so much. Kostya, let me pass it back to you here for a little bit. Talk to me about Neu.ro at a very high level. And then as Dean gets ready, we're going to hear about a little bit about what Cato is actually doing as well. And everybody on the call, you're going to get some updates because Cato is always doing some fun things. So Kostya, what are we doing to make a lot of all of what we're talking about possible?
Yeah, so Neu.ro is end-to-end ML orchestration platform. And that means it takes everything up from very low ground hardware level and generates an environment so that ML development teams and end users of technology, these researchers and programmers who build ML and the modeling, can just plug in and start working without skipping a beat, right? Without worrying about hardware, DevOps, and whatnot. And specifically with Cato, we sit on top of Cato infrastructure and we enable this tooling seamlessly to the community of ML developers. And I see there's a question on legacy GPUs and DPUs, how they can be used with generative model. That's where Neu.ro comes in, right? So integrating all that legacy GPU supply and modifying it so that the models, state-of-the-art generative models, can indeed fit on legacy GPU and second life hardware is what we do, right? So this enables kind of to abstract away all the complexity away from the end user. So if I'm an ML researcher and I'm building another, GPT-like clone for my enterprise, I just come in, push a few buttons on Neu.ro, and I have my compute, I have all my tools, and I'm ready to go. I don't even notice if I am on, it's basically an experience equivalent to working with a hyperscaler. Like you go into AWS and all the tooling is there. Similarly here for Cato.
Yep. We simplify you all to become data scientists. There's a great UI. It's easy to interact with. It's not difficult to create your models. And also the ingestion point, data can come from anywhere. There's a question around, for example, a manufacturing facility with multiple locations. Yes, absolutely. You can do with multiple locations. Site-specific knowledge can be worked on while maintaining very deep levels of privacy. So that's really important. And, Costa, I'll bring you in here in just a second here to talk about our awesome talent. But that's what we do. We apply talent, tech, and experience to solve these really complex real world problems sustainably with machine learning and ML ops. We have data scientists, we have AI scientists, practitioners. We partner with industry leading companies like Cato to develop truly transformative AI solutions. Like I said earlier, this isn't a platform for only people who do AI. This is a platform for anyone. We want to create an AI architecture and ML ops platform for all of you so that you could too be where that puck is going. We've experienced so many conversations, especially over the past few weeks or past week or so. And Costa, you can talk about this, about the ethics of AI, how we as an organization not just deliver the sustainable, but we focus on AI transparency, AI ethics, data control, and we make sure that we're not hiding anything. And that's a really important point to understand. Costa, talk to me about the wonderful people that make up Neu.ro, who we are, and certainly some of our talented folks.
Yeah, no. So Neu.ro has a story. Initially beginning from a bunch of data scientists and researchers who a few years ago were trying to develop the models for the industry and consistently hitting brick walls in amount of orchestration and just DevOps tasks for ML code, MLOps that the team had to deal with. And the idea was, look, like this has to be simplified, this has to be corrected for. And also we were, even at that time, cost conscious. And one of the ideas was, well, there are these pockets of GPU arbitrage where we could work at lower cost if we could just deploy the right tools there. And that was kind of the gist, the germination for Neu.ro platform. So not only we understand engineering and end-to-end stack from hardware to specific ML tools real well, we also understand the models. And some of our data science teams have a bunch of accolades actually, and some very strong academic activity building these state-of-the-art computer vision and natural language processing models over the years. So not only we know the tools, we also know the craft.
Mm-hmm. The tech behind it is also very powerful. Obviously, this is just a screenshot and a one slide. Powerful, sustainable, and flexible AI/ML development in any cloud or on-prem solution or architecture, public or private. It's all accomplished with a focus on reducing data's carbon footprint, and also, again, really important, maintaining AI ethics. That's so important for us and everybody. Not just say it is us, but certainly everybody. And there's a lot of experience here from what we've done. Costa, can you talk about a little bit about where we've had some of these deployments and some of our experiences?
Well, yeah, so specific work we have done for quite a few clients all over the world over the years. And this has to do with very sophisticated model development. Some of our models are actually running in your cell phones, doing visual processing and whatnot. But the up and down implication of it is that we have experience building up these development gardens for ML research teams, stitching together hardware and infrastructure from the very low engagement to the huge multinationals with dozens and dozens of people in ML development teams.
So for everyone listening, quick elevator pitch, and then Dean, you're next. Why Neu.ro? Costa.
Yeah, so I'm going to give a concrete example, right? Like, let's say your organization needs its own GPT clone. And for whatever reason, maybe you're in healthcare, maybe you're somewhere else, you just can't send your data to Microsoft. There are tons of various issues with GPT APIs from OpenAI. Number one, they have their biases. They were trained on specific data. You don't know what they are, and you can control some of these outcomes. And then again, these GPTs, they memorize the data. So you can't really, trust the third party. You have to do it in-house. And if you have to do it in-house, you have to do it properly. You have to have the proper development environment from the hardware to the software tools. You have to have proper examples. And that's where Neu.ro come in, creating these wall development gardens for your enterprise end to end, so you can fine tune and use your own GPT, controlling the data, controlling the costs, and controlling the outcomes. And
Very cool. Thank you, Kostya. Dean, you are our engine, man. We're deploying right on top of you. So we've learned about why Neu.ro. We've learned a bit about Cato. But why Cato Digital?
Yeah, I mean, this really comes down to we want to be sustainable. So our key here is it's low cost and low carbon. So low cost, we have to be able to manage that. Low carbon, we must be sustainable from day one. To do that, we have to do models like this. So what I love is that here you've got the technology on top that people are going to consume. Then underneath it, those people should not have to worry about how it's getting done. They should be able to leverage the capabilities of a platform like what we have, right, that Neu.ro is running on top of, that we're delivering that sustainably so that we can keep just driving the business forward. So that's why the core tenet is to go back and say, we're going to deliver a cost-effective, bare metal experience that is highly sustainable. So, and I think that one other piece that's really important in this is the balance. So everybody said when cloud came out, it's going to kill the data center. Everything's in the cloud. Cloud is a data center. It services on top of these different things. In the end of it, cloud boosted digital infrastructure globally. It became half of the actual new investment, right, globally, and the consumption. But there's still a huge amount of that that's going up. There's always hybrid infrastructure. There's multi-cloud. There's a blend between on-prem and cloud. No matter what, there is not one size that fits all. And I think this is what Constantine and Bill have been talking about is you are going to run your business and you're going to be driven by different factors. Those factors are going to lead to where you're consuming infrastructure. And also, all the infrastructure may not be able to meet all of your needs, which is hence why you're going to use other pieces. For us, we're going to put 1 million servers in 1,000 data centers. Plain and simple. We're going to use everyone else's waste to deliver the most sustainable compute platform we possibly can, tied back to the IMASE's climate accord and our, I think, responsibility to make sure that we are doing sustainable computing regardless of the demand. So you'll get a lower cost. You're going to get lower carbon just by leveraging the platform.
Very cool. And wow, it looks like you're in a lot of places.
Here we go.
Yeah.
Yep. We're going out. We're in California. We're in Lagos, Nigeria, right? And more to come. Next week is going to be fun.
That's exciting. I can't wait to hear that. We're going to open it up for questions. I'm actually going to put up our contact information here as well. You're welcome to reach out. Follow us on Twitter, Instagram, Facebook, wherever. Pick your favorite forum. There's a couple of questions that are coming in here, and we do have just a couple of minutes. Greg asked a good question. How big of a risk is ChatGPT for protecting IP as engineers use it to solve work and sometimes proprietary challenges? Great question. Literally something we just talked about. And so here's the thing with that. I'm not kidding. In early April, I'm speaking at a security forum, and one of the things that I'm talking about is ChatGPT and how employees have been inputting proprietary information into the ChatGPT bot. Like, hey, enter in like, critical IP statement here. How do I make this better? And then obviously Costa talked about this, like, hey man, it's stored, and like you don't really know where you're sending it to. That's where working on a more private, your own trained model, your own control of the data becomes really, really important. So that's a really, really great question there. As far as security and privacy, Dean, anything you want to add to that?
So the one that surprised me the most is, hey, write me code. So, but here's some input code. I want you to go back and write the next extension. That right there, just from the IP standpoint and others. So where your data is and who's processing it, where that data, what is it? Breadcrumbs across all of that. There's just Hence the ethical part of this. Where is it? How are we doing it? Just like anything else, you have controls in place to make sure. So I love the fact that you'd say, I've got my own safe playground to run something that meets all my requirements. Right? That I can keep that in there. Hence, it's going to be in a lot of different places. But companies have to think about what it means to move your data around to run these models.
Brilliant. And Kostya, any final thoughts to help wrap us up here as far as the risk?
The risk is great. I mean, these models, they're memorizers. So if you give it a piece of code, a piece of proprietary data, it's going to keep it in context and it can spit it right out. Microsoft promised not to train on that data, but then, you just don't have control. And, then there is Anthropic, there are dozens of other enterprises, and you never know where your employees go to get this functionality. So you have to better get it yourself or equivalent.
Perfect. All right. We are at the top of the hour. There are some questions here and comments that I promise we'll get to offline. I know that this is a crazy, crazy fun topic. With the 1 minute left that we've got, Dean, any parting words?
Yeah, I am super excited about what Neu.ro has built, right? This is not just something that's going to be in the future. It literally is a platform that's scaling and doing this work right now. What I'm also excited about is that we can now contribute to enabling that platform to be adopted sustainably by many, many, many people. So that's why, Bill, it went from conversations at PTC to GPT-like capabilities. Bam, in 2 months.
Wildly Hawaii to this. Kostya, any final parting words for us?
Huge thanks to Cato, which is enabling us to do this in a sustainable fashion. This is, a concern again, and I think we're going to be able to tame this monster at least a little bit.
Doing our part. Thank
you so much, Dean. Thank you so much, Kostya. Thank you for everything Cato is doing, and obviously thank you, Kostya, and to our team at Neu.ro. We have a lot of questions, a lot of comments. We'll try and get to those offline. Again, this is where the puck is moving. This is where this industry is going. Come hang out with us. Let's do this together. Let's train some models on sustainable hardware and infrastructure. And it's going to be an exciting time. As a final note, be sure to follow both Cato Digital as well as Neu.ro on all the fun social medias out there. I am in a perpetual competition with Dean to try and take more selfies than him. I'm losing. And a final, very happy International Data Center Day to everybody. That's today. So go out there and go high five a server rack or something. I don't know. go call a data center awesome.
A data center.
There we go. There we go. High five a data center tech. Thank you everyone for joining us. Thank you for hanging out with us. We're going to make this available on demand so you can share it with people as well. But meanwhile, have a wonderful rest of your week. Everybody, thanks for joining.